Hello guys, new episode of the Sandbox project, and it's Procedural Eye Material. I will also use it to make sort of funny spooky eye pawn, so it can be used in horror games, whatever you like. Also, it's just the proof of concept. It's not anatomically correct, I guess, but I think I've made it quite valuable. So, everything that you see here is all our material. It's very adjustable, so you can adjust vines, purple, iris color, also pretty much everything. And here is the logic for our spooky eye pawn. So let's begin with the basic idea. So eye consists of several layers, so do my material. I use simple sphere and apply this shader on it, so you don't need to have different geometry, simple sphere shape. Also, to make it look like an eye, I used radial gradient exponential to receive this sort of circular masks. What else? Also, I have noise nodes with different attributes inside, and they are pretty much predefined, so you can just bake out the texture if you like, or you can adjust it here, make the prototype and then bake it out. What else? Also, I have subsurface shading model. The vines goes into the subsurface color, and iris, purple and other stuff goes to the base color. Also, for now, with the 5 here to the roughness to make it shiny as an eye should shine, I guess. So yeah, let's start with our vines. So this one is to make our noise nodes stable without any changes due to, like, if we start moving with our character and our noise node is applied on the material on a static actor, the pattern will be changed due to camera change also. So to make it stable, we need to make our position bind to the texture coordinate. Due to this should work with the vector 3, I use texture coordinate and append 0 at the end, so it's our z-axis with 0. Here you can see my layout of the noise. Let me quickly show here. So scale 8, higher scale is, the more vines you will receive. Also, I set it to be tiling and the repeat size 4, so you don't see any sort of cuts, so it's fully tileable. Next thing is to adjust levels, so the lower level is the more visual outlook of the vine you will receive. So if I go with 3, you can see it's not as clear as I guess it should be, but it depends on the user needs. Also, output minimum is minus 0.1, because if I go with the default value, it's fully covered with the black color. To adjust it, to make it look more as vines, you need to go something small. Even go with, you can see that our vines are a little bit tiny, so play around with this value to achieve proper result. Also, function is gradient texture based because it can be tiled. So everything, I guess, clear here. Next step is to define the white area and red area for our vines. Because if you see, we have the black one is our lines. We need to invert it and multiply by the color. The next thing is, so our white becomes, so these areas with the white should be also like colored. So if we apply them together, we will receive something like this. Our eyeball, it's our like the base model. Next thing is to make the masks for our pupil, our iris, etc. So here you can see like pretty much the same logic here. The reason why I use multiply by 2 and 1 vector is just to cover a lot, like this radial gradient exponential function actually sorry guys, covers our sphere with a little bit artifact. So to get rid of this artifact, we need to have sort of offset on our center position, and to make our texture coordinate also be extruded on the x-axis. So if it's extruded, if it's applied on the sphere, we will receive like an ideal eyeball. If we go with the value of 1 and 1, our pupil will be stretched and it will not be look as a circle. Next thing, as I said, is our masks. So I use radial gradient exponential. As you can see, each of our layers have the same offset on the center position, the same UV and the same density. Difference is on the radiuses. So start with, as you can see, it's like the overall shape that should be used between our iris and our vines, so the white area. Next thing is our iris, so where our color start begins. Iris also have the contour, so we have the smaller one here. As you can see, and if we subtract from 1 this sort of contour, it's the contour of our iris. Next thing is to have the pupil. So from the bigger one here, we need to subtract the small one. It's our pupil, and we will receive something like that. So yeah, our black here is our pupil. What else? Well, as you can see, let me just make it more clear for you. So yeah, that's how the eye looks. Pam 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 pam. So our base, if we subtract it from our iris start, our iris inner, not inner, our outer edge, we will receive this like area that should not be covered with anything. So on our black here will go iris, on our black here will go our vines. So that's why let me just stop it. We have our mask here. Then from our iris start, we need to have the invert one, and this invert one will be colored with our vines. So just wait, I'll show you. So this area, this white one, should be covered with our vines, and if we can combine this mask, the result of these two operations with this one, we will receive it's like our not colored area with the colored area of vines, and this black one is good for our iris. And this, like the result of these operations, are going to be our subsurface color. Next thing is to add all our results here. So this is our iris contour, we multiplied by color, and this goes to add to our basic basic mask. So we are adding one mask to another one. Next here is the you can actually see that they are the same, but with the little bit difference. It's to make our iris more beautiful, to have like the noise inside it. So the same as here, but the noise pattern is different. Scale, gradient, levels. Play around with these values and also play around with the iris main and secondary colors. They should not be much different to make our iris look more realistic. And then this one is multiplied by the result of subtracting this mask. So from our iris contour, we are subtracting our pupil size, and the whole area, this one, should be colored with our iris color. And then the result of this is also added to the result of computation this and this. And let's go to our base color. Also add Fresnel, and our eye is actually done. It's quite easy, it's quite beautiful result. So, yep, next thing is to talk about our little spooky eye pawn. So, our spooky eye, it's simple actor, as you can see, with this setup. Sphere, here I apply my material on it. It's even not the material instance, just simple material. I have some changes, so you need to do this also. You need to rotate on that axis of eye, so when we need to track like our character with this eye, basic relative rotation should be 90. Scale is just for me to make it bigger, to make it more spooky. And I have the spherical vision, which I call pseudo sight. Sphere radius is 1000 units, but it can be adjusted. Also, as you can see, it's custom collision, which ignores everything but overlaps with spawn. Nothing fancy here. On the event graph, I have the following logic. So if we start overlapping with our character, we store it as actor to spectate. Then I have the custom event, which is set to be looped every frame, and the function is called track. If we stop overlapping with our pseudo side area, and the other actor is our actor to spectate, We need to clear and validate our time so the logic won't be ticking, and the spooky eye won't be like trying to search for our character. As for the track, I check whether actor to spectate is valid. If it's valid, I go with the logic. If it's not, I clear and validate our time. Everything simple. So, I use set actor relative rotation for our eye. Here I use find look at rotation, the start of actor to spectate location, and target is our spooky eye. I use rotation interpolate 2 with the speed of 8, so it's not, it has some sort of rotation lag, it looks more smoother. Actor rotation goes to current, and the result of this computation goes to the target. Next thing is to set scalar parameter purple. So yeah, if the purple, if something is in close range to the eye, the purple should, if I'm not mistaken, should squeeze and be smaller. If something is at the like long range, the eye extends, the pupil extends. So here I use distance between actor location and spooky eye, and I use map range clamped with this value. So in range of 400, out range will be 0.05. In range 1000 unit, it will be 0.18. So in close range we will have the small pupil. In long range we have the big pupil. So as you can see, set scalar parameter on materials, and because our sphere has only one material, this one, we can use this node without using and creating the dynamic material instance. Also make sure that these values are not higher than this one, because if it's so, you will have some artifacts. Also, to make it work precisely correct, the default value for our pupil should be our long range, like this one. And all you need is to add character. You can use even it with the foliage cover, like foliage mode. Sorry guys, foliage mode. So you need to add it, like you can add the blueprint text to the foliage painting tool, and like cover everything with its eyes, and it will be like creepy scene. So let me demonstrate one more time. You go here, eyes, concentrate on us. We are going back. Our pupil are changing their size. And that's actually it. So guys, I hope you like what you saw, and as always, my Patreon, my Discord, everything is under the description to this video, and see you soon.